All right. Hello, everyone. Okay, I figure we're close enough now. So I'm assuming everyone, you guys can all hear me. At least somebody can, right? All right. So today's going to be kind of a half and a half. We're going to have to spend time at the beginning doing the whole administrative type of things, kind of laying out what's going on with the class. And then we're going to jump right in. And so I guess I'm going to go ahead and get this administrative stuff done. If at any point you have a question, please feel free to type that into the chat session. You may have to get my attention if I'm really on a roll. But yeah, this class, feel free to ask questions at any point in time. They always say there's no stupid questions, but the reality is you're going to be essentially learning a brand new language during these last 12 weeks and a new way of thinking. So if it's a question that hasn't been asked, I bet somebody else has that same question. So please feel free to ask questions at any point in time. All right, Comp 111, hopefully that's the class that you're expecting. Okay. All right, so session objectives today, we're going to do the whole introduction thing, course expectations, and then we're going to jump into doing an introduction to classes and objects, variables, data types, naming conventions, and then do a homework overview. I do just kind of want to go over, so what it is this particular semester is I'm actually teaching two sections of Comp 111. So I'm combining you together as far as these meet session goes, and that is totally to your advantage because what's going to happen is Thursday is going to be our meet session. So this will be like our class session where I go over topics and explain things in reference to PowerPoints. But because I have two classes, I have to hold two meets. So on Tuesdays, I'm going to be holding Q&A kind of meets. And so those are all about like ask me questions, let's talk about the homework, let's talk about the labs, let's clarify some concepts, let me go over examples. So you guys actually benefit from the fact that I have two sessions because normally there'd just be the one meet session, but because I'm teaching two classes and have to have two meet sessions, you get not only class time, but you also get this kind of like online example time as well. Now the Tuesday Q&A session is totally optional. It will be recorded, but last semester I did the same thing last semester and students thought it was just amazingly helpful to have those sessions. So hopefully you guys will benefit from it as well. All right. So my name is Tina Compston, and I've been an instructor here at Franklin, I don't know, for like 12, 13 years. So I'm a part-time or an adjunct instructor. I've been working in the industry, the computer coding industry, however, for well over 30 years. And my daytime job is at Ohio State University. I work in the Student Health Center there as a programmer for them. So I'm still in the industry, still working, and so I believe it gives you a great advantage to have someone with so much experience. I can definitely relate, explain things, how they've been. I can give you lots of real world examples and really try to help you understand these concepts. As far as the best way to contact me, email is definitely it. I check my email several times throughout the day, Monday through Friday. Saturdays is kind of iffy for me because I'll tell you, by the time Saturday rolls around, I'm kind of sick of computers because I've been working on them all week long. But I'll check back in on Sunday at least once or twice on Sunday. But usually during the work week, I'll check 3 or 4 times during the day and try to respond right away. When you're emailing me, if you're having questions, especially in regards to some code that you might be working on, a solution you might be working on, don't email me and say, I don't get the homework, because then I'm going to have to email you and go, well, what is it that you don't get? And we're going to play this back and forth game, which just delays getting the answer to you. Provide me with as much information as you can, like, here's my code, here's what I've tried so far, here's the error messages I'm getting, and this is where I'm stuck. And that will help me to know where to direct my response to you to get you unstuck and back to working. Okay. Piazza, there's this new tool that we are now using, and you will actually, you've probably already started getting some emails on it, but you will find that here. It's in the extra credit link. Okay, so right here, if you click on the extra credit link and then you click open, it will actually open you up into the Piazza site here. You can see there's quite a few posts that have already occurred. If you want to see any posts related to homework 1, you can click on those links across the top. You can post questions out here or read questions that other people have posted. You can post answers out there. It's this great tool that they've started using within the last year or so. So what it provides you with is not only do you have me to help you with your answers, but you now have me, you have Edgar, who's another instructor for the class, you have all of the students in all 3 classes. Everyone can come to your aid in Piazza. When you're posting questions out to Piazza, however, do not post your entire code solution, because not all students would be, because somebody might take advantage of the solution that you've posted and represented as their own work. So instead, maybe just like a line or two, I'm getting an error on this specific line right here, you know, or if you need to post your code, you can post it to the instructors only. But definitely take advantage of this Piazza tool. It's also the only way to earn extra credit in this class. So with Piazza, what it ends up being is kind of a bell curve at the end. There's 30 possible points. Whoever does the most posts and the most answers and the most views will earn the whole 30 points, and then it gets prorated down from there. So take advantage of the Piazza site. It's awesome. Course layout. So each week, this is what you can expect to encounter. So you have assigned readings each week. Depending upon, you know, how quickly you read or how much there is to read, that'll be a 30 to 60 minutes you'll spend there. There's this online meet session, which is 60 minutes. If you attend the Q&A as well, that could be another 60 minutes. The guided learning activities, there's no points associated with them, and they're definitely optional. However, what the guided learning activities represent is what you would have accomplished had you been in a face-to-face class. So the face-to-face class for this would be 4 hours in a week, right? That you would physically be sitting in a classroom, 1 hour of which would be like what we're going over with this meet session, but there's a lot more that would happen in that session as well. And these guided learning activities represent what else the instructor would be doing. So if you choose to forego those guided learning activities, you're essentially choosing to forego those extra couple hours of class, right? And they can really be very beneficial as far as learning the information in this class. Homework, labs, exams, depending upon the particular week, you can expect 30 to 200 minutes on those. And then there's a reflection paper that you'll be, should be like contributing to as we go throughout the course, 30 minutes for that. So each week you can expect to invest between 180 to 380 minutes. And 180 is on the low. What do I want to say? So here's the thing. The first couple weeks, you're not going to invest all that much time in the class, right? Week 1, we're just kind of doing introductory stuff, getting your feet wet, helping you out, helping you learn the different tools. Week 2, a little bit more, and then we're going to start jumping in and just slamming you with stuff the remainder of the course. So for the first couple weeks, you might only spend 120 minutes or whatever on the course, but you can expect from like week 3, week 4 on that you're going to be closer to that 380 mark than you are to the 180 mark. It's a very labor intensive course, because you got to keep in mind we're teaching you a new way of thinking and a new language. And you wouldn't expect, if you were going in to learn Spanish, that in 12 weeks you would be 100% proficient without investing major time, like totally immersing yourself in that language. And the same goes true with programming. So you need to keep in mind when, if you get frustrated or whatever, that you're like, oh my gosh, this is so much harder than I thought it would be. You're learning a new language and a new way of thinking, and that's hard, right? Okay. Attendance. So in an online class, we're not, I can't physically take attendance and see who's participating in things. So attendance is equated to the submission of an assignment, whether that's a homework, an exam, or a lab. It is not equated to this weekly meet session, because the reality is it's very hard to participate, right, in this weekly meet session. So the submission of completed homework, exam, and lab is going to be attendance, and it counts in the week in which it is submitted. So not in the week in which it was due, but the week in which it was, with the okay, so I should qualify that. All of our homework in this week is due the Wednesday of the following week. Okay, so yeah, it still counts in the week in which it's submitted. So everybody gets a pass for week 1 because there's nothing that needs to be submitted, right? So everybody's counted as in attendance for week 1, but in week 2, you need to submit your week 1 homework, so that's going to count towards week 2. But if you're running late, then you don't submit anything in week 2, but you submit the week 1 and week 2 homework in week 3, that counts towards attendance in week 3, all right? So it's the week in which it's submitted. I think we're almost done with this stuff. Grading. So Franklin's policy is everything is graded within 5 days after the assignment is due. You're due on Wednesday. That means everything has to be graded no later than Sunday. I really try not to delay the grading. I hate it when there's stuff just sitting out there, when an assignment due date is passed and your stuff is sitting out there. So I try to do my best to really get the grading done as quickly as I can. So, I'll shoot for, well, Thursday we have this chat, but if I can, I'll get some of it graded on Thursday and then work on Friday and Saturday to get it graded to you, to get it out there. When I'm grading, if there's no submission in the grade book after the due date, I'm going to stick a 0 in there. That's not necessarily permanent. It's just kind of telling me I already looked at this person, nothing was submitted, and it tells you too, hey, a due date passed and I didn't submit an assignment. Just in case you thought you had, it gives you that kind of reinforcement. As far as late policy for the course goes, you can submit assignments up to 3 days late. 1 day is 90%, 2 days is 80%, 3 days is 70%, and anything beyond that, I am more than willing to evaluate, but you won't get a score for that particular grade. In grading your homework, I will always provide feedback on questions that are missed or where points are deducted. And I'll upload that right back to the Dropbox so that you guys can see that. But if you don't do a problem, I'm not going to give you the answer to it. All right. So if you try it and give it, your best effort and get it wrong, then I'm more than willing to provide you the solution. But if you just leave it blank, I'm not going to provide you the solution for problems that are not attempted. Okay, I think we're almost done. Exams, they're all online, no notes, no book. You can use scrap paper to help you scribble things out, but other than that, that's it. You can use a face-to-face proctor or an online proctor. I believe Franklin is encouraging for these courses proctor you as your online proctor. You need to identify those in week 2 using the online proctor form. And that is my whole involvement when it comes to proctors, is to tell you guys that you need one. All right. The testing center is deals with all proctors. So if you have questions about a proctor or you need to change your proctor, you need to contact the testing center, because other than me telling you you need a proctor, that's it for me. And I would just forward your questions on to the testing center anyway, which I'm more than happy to do, but you can cut out the middleman by going to them directly. Assistance with the course. So in this class, each week builds upon the previous week. So you can't just skip 1 week and move on to the next week, right? And think, oh, I didn't get this concept, but that's okay, I'll just keep going. Each week we build upon the previous week. So think of learning a new language. You can't write sentences. Once you learn verbs, you're not going to write a sentence without a verb. You know what I mean? Like it just builds on each week. So if you find yourself not quite understanding a concept, you want to act right then in that week. And the tutoring, the SLC, the Student Learning Center, has amazing tutoring for this course. I've never had anybody say that the tutoring was bad. They've all spoke excellent, had said excellent things about the tutoring. So, but after about week 4, the tutoring for this class is going to fill up fast. So if you know you're struggling, schedule that tutoring as soon as you can, like at the beginning of the week or whatever, or maybe even schedule regular tutoring sessions, every week. You can always cancel if you don't need it, but you'll find that come week 8 or 9, it'll be 2 weeks out. Like the earliest available tutoring session will be 2 weeks out. So you want to take advantage of it and get scheduled and get in there as quickly as you can if you find you're struggling with a concept. Okay. So it's a great question here. 2 great questions. So as far as the exams work and the test with this particular class, you're not going to be you're just going to be typing in code snippets into the online. So you're not going to have a tool. In Comp 101, which is like an intro to the intro, it uses Python. You get to use a reply it tool when you're writing your Python code. For this class, we're not going to have BlueJ or anything. You're just instead of taking the test by paper, you're taking it online. And the other question is, they have both face-to-face tutoring and online tutoring. So they have both types of tutoring at the SLC. And our tools, we are almost done with this. Okay, so the tools for the course, we have a BlueJ editor, which you hopefully have all downloaded at this point. You don't have to use BlueJ. If you have another editor like Eclipse or something that you're more comfortable using, you are more than welcome to, well, Notepad does not compile or execute. So you can definitely type your code into Notepad. Well, yeah, you could use the command prompt. So you can use that. But yeah, so you want to make sure that whatever you're in, that it's going to let you compile and execute the code so you can see the results. But if, BlueJ is provided by the university as a free tool. So if you want to use BlueJ, that's great. That's what I'm going to be demonstrating in. But if you like Eclipse or something else, you're more than welcome to use whatever it is that you like to use. The only it's not a disadvantage, but a couple extra steps that you'll have to take is when you're submitting the labs to WebCat. Franklin has built an automatic hook into WebCat or into BlueJ that automatically connects with WebCat, and your other Eclipse and Notepad and things like that won't have it. So if you are not using the Franklin version of WebCat, absolutely, you can just create a compressed or zipped folder, copy all of your lab components into the zip folder, log on to WebCat, and submit it manually. And then every time you want to submit to WebCat, you'll just have to repeat that process. So it's not cumbersome. I've done it plenty myself. You just need to be aware that that's the steps that you'll take. I don't know. You'll have to try it, Jamie. I've only tried uploading a zip file, but you can try one of the other files and see if WebCat takes it. You'll need your compiled class and test class. It may actually compile it. So I think you'll need both the class files and the Java files and the readme.txt file too. But we're not going to do labs for another week. So WebCat is a tool, so that's used for lab submission only, not for homework. The username and password is the same as your Franklin course. When you're working on your coding problems in the homework, definitely use whatever editor you're using. Like, you don't have to sit there in Word and try to figure things out. Go to BlueJ, go to Eclipse, go to whatever you're using, execute them, try them out, and then make sure they compile cleanly and test them so that they actually work the way you're expecting, and then copy it from BlueJ or Eclipse or whatever you're using and paste it into the Word file. I mean, that's a tool for you to use, so take advantage of it. And to be quite honest, when I'm grading, I'm going to copy it out of Word and paste it into BlueJ, and I'm going to compile it and I'm going to execute it. So you want to make sure that they will successfully compile and execute. Macs versus Windows. So I'm not sure if some of you guys are running Mac machines. Anybody running a Mac out there? Okay. So I put some information out on the course website regarding Macs versus Windows. I'm going to tell you, I can turn on a Mac and I can painfully navigate through a Mac, but that is the gist of my knowledge when it comes to Macs. Or, you know, and like Linux, I can get there, but I can't really. So, you're on your own. All right, so you can download BlueJ directly from the BlueJ website for the Mac, and then you can do the compressed folder thing for your submission, or you can build a Windows environment on your Mac and do stuff there. That link that I put out on the course website is what other students have told me they've used to get their Macs working. So I cannot speak to the correctness of that. I just know that other students have said that's worked for them. So good luck. Actually, you should be fine. Submitting to WebCat via the compressed folder is just like 2 extra steps, so maybe an extra minute to the process. So it's really not cumbersome to do it that way. All right, and I think this is my last big slide here. Internet, is it cheating? Sometimes, okay? If, you know, the internet is amazing, right? I'm on it every single day. I don't know that there's a day that goes by that I'm not, well, except for maybe Saturdays because I'm sick of computers, right? But that I'm not on it. I use it all the time when I'm trying to find things out at work, you know, trying to figure out pieces of code, snippets of things. So, which is great. So if you're struggling and you go out to the internet to try to help you understand a concept, that is fine. If, on the other hand, you're struggling and you go out to the internet to try to find the code and you just copy that code and paste it into your homework, that is not fine. And I can almost always tell because no one has yet to copy stuff from the internet in the hopes that they get a D, right? Usually they're struggling with the course, having a D or an E grade in it at the current point, and all of a sudden their coding is, wow, out of this world fantastic. And so that's a red flag to me, like, okay, what happened here? And so if I look at your code and I'm thinking that it's looking pretty advanced or maybe not what I think has been your typical code writing, what I'm just going to do is I'm going to challenge you on it and I'm going to say, all right, you've submitted this code, here's some data, I want you to walk me through your code using this data line by line and explain it to me. And if you can do it, then I'll give you credit for it. And if you can't do it, then we'll have to have a whole nother conversation. All right, so just keep that in mind. Use the internet as a tool. Don't use it as a means for not having to do your homework. And just a last thing, never write your code in Word. Always write it in your editor, whatever editor is of choice, so you can compile it and test it. And mostly because Word tends to capitalize and do all this, insert different characters and things that just do not work in BlueJ. Okay, so we have the question that when we're working on a problem, if there's a library out there, for instance, in the Java libraries that maybe maybe you need to calculate the absolute value, so you go out and look into the libraries to see if they have an absolute value calculation. You can definitely use those as long as the point of the assignment is not to write that particular code. So an example will be in week 9 or thereabouts, we're going to write some sorting algorithms, and there are definitely libraries out there with sorting algorithms. You're not to use the libraries in that case because the point of the assignment is to specifically write your own sorting algorithm. Okay, so you can definitely use the library as long as that's not the whole intent of the assignment. Oh, I think we got through all of that stuff. Is there any other questions on that whole Franklin BlueJ, if you're downloading from the class, like if you go into the class, you'll get the one for Windows from the Franklin BlueJ site. That's the one that you want. All right. Okay, so we're going to jump in. I'm going to start. I'm still watching here because I can see other people are typing. Okay, great. All right. So, oh, you didn't get the Linux Franklin? No, yeah, because it's Windows version. I think the Franklin BlueJ is only for Windows. All right. So we're going to jump in and we're going to talk about classes versus objects. And I'm going to throw a ton of terms at you in 30 minutes. So I have 30 slides to do in 30 minutes. So it's going to come really fast. All right. Don't worry if you're confused because we're going to go over this again next week. And we're going to go over it again in week 3 because these are the key concepts for the whole course. All right. So you may be at the end of this. So I should ask, is there how many, is there anyone that this is your very first attempt at programming ever? Okay, so if this is your very first attempt at programming ever, you may leave this first class going, oh my goodness, what have I gotten myself into? Okay, so don't worry, we're going to go over this again and again, and we'll get you there, all right? So if you see or if you're sitting there thinking, everybody else seems to be getting it and I haven't, probably they've had some previous experience, okay? You know, so hang in there and we will get there. We will get there together. We're going to make this happen. All right, so has anyone ever built something kind of like a house or maybe put together a desk or something along those lines? Chicken coop counts. All right, and Legos count as well. That's awesome. All right, so before building, what did you use to know how you were going to go about building that? Chicken coop, Lego bricks, whatever it was that you were building. Manual, instructions, there you go, or a blueprint. Exactly what is going for, Andrew, a blueprint. Okay. Now, so you might have a floor plan, a blueprint, and a blueprint could have a lot of different pieces, right? It could give you the physical structure, then there might be a plumbing blueprint, an electrical blueprint, and so on, a foundation blueprint. So this gives you the instructions that you're going to need to know in order to build this house. All right. Now, can you live in the blueprint? No, you cannot. And this is a very key concept right here. So hang on to that. Like, why is she asking us this weird question? Hang on to this one. All right. You can't physically live in a blueprint. You could maybe build yourself a paper house, but yes, it would not be comfortable. But you can use it to help you build a house that you can live in, right? All right. So can we build more than one house from a blueprint? Yeah, we see them all the time with all the track homes, right? MI homes, Dominion homes, all of that stuff. All right, do all the houses built from the blueprint have the same address? No, they're all different houses. Okay. Are all the houses built from the same blueprint exactly the same, like inside and out? No. Some might have hardwood floors inside, some might have carpeting, some might be blue, some might be green. They all have their own individual attributes. Okay. A class, which is, this is object-oriented programming. Java is an object-oriented programming class. So a class is our blueprint. It's used to build an object. So you can't live in a class. You can't store data in a class. Okay, there's no data or anything in it. It's just the instructions that are going to be used to build your object. So a class can't be lived in or data can't be stored in it, but you can use it to construct your object. Now an object, on the other hand, would equate to our house. And an object can store data and we can take action against that data as well. So our class is our blueprint, our instructions for how we're going to go about building or constructing our object, and the object is where our data is going to live. This is where, this is the same thing as our house. Okay, so when an object is constructed, we allocate space and memory. We give it a street address. If you're thinking of a house, we give it, allocate space and memory, so a memory address is associated with that object, and then we can store data inside of that object, so you can actually move in and live inside of that house. All right. We can create multiple objects from one class. So just like we can use a blueprint to build a whole bunch of houses, we can use one class and create a bunch of objects from that particular class. Each object is going to have its own location in memory, its own street address, and each object is going to have its own unique attributes or data. So each object will be customized, just like a house would be customized with different colors and landscaping and things. Okay. When we're creating these classes, what we're going to be creating a bunch of, for our purposes, will be what's called user-defined data types. So they're brand new data types that we're building that will allow us to create these objects. So it defines the type of data that's going to be stored in it and what actions will be taken on that data as well. So there's two pieces to each object, and the class defines this. The class says, this is the data I'm going to keep in this object, and these are the different actions that I'm going to allow you to take against that data. So for instance, we might create a class called dog, and we can build a bunch of dog objects. And in that object, we might want to store the name of the dog, the breed of the dog, the age of the dog, and so on. So that would be the data or the attributes that we need to know about that dog. And then actions we might take might be like, I want to change the name of the dog, or I want to retrieve the age of the dog, kind of a thing. And we can do other calculations and things as well. A data type. Okay, so a data type is like a person or object inside the house. Yes, the data is the information I need to know about that particular object. Okay, so I might, in the case of a house, I might need to know what the square footage of it is, the address of it is, the owner of the house. So it's whatever information I need to know about that particular object is going to be your data that's stored in it. So Owen, you are really close. Yeah, so what Owen has showed here is almost the format for constructing an object. Missing one key component, but you are really, really close, Owen, so hang in there. Well, now you're missing the data type in front of Duke. And Duke wouldn't be capitalized, even though, yeah, so really, really close. All right. So here we're going to go about like creating a class. So we would define our user-defined data type class that then can be used over and over and over again. So then we can actually use it in a program. So we create the classes and we have to build them and test them and make sure they work. And then we can use these classes inside programs to create objects and manipulate the objects and things. So for example, we're going to create a class called pet. A class name should start with a capital letter. That's a Java naming convention, so it's always going to start with a capital letter. So we have the capital P here. And then we need to figure out like what data do we need to know about this particular object. So what information would we need to know about a pet? Yeah, Hassan, you were right on there. Dog, Duke, and then equals new dog. But Mastiff may or may not be in there. So we would need to know the type of pet, the breed, the size. Is there anything else we might want to know about a pet? The age would be good. Color, temperament might be useful. Oh, vaccinated or vaccination status, maybe, something like that. Yeah, all those are great things. Now, for my purposes, we're just going to go with a couple pieces of information. Oops, did I skip that? Okay, so those are all great things that we would need to know about a pet. We'll then build inside of our class. So once we've identified those items, those are the data we need to know. Those are what's called instance variables. So all of these age, color, temperament, size, breed, all of that would be called an instance variable. It's the data we need to know about our object. And remember, I'm going to throw all these terms at you, but we're going to go over this again and again over the next couple weeks, okay? The next thing we have inside of our class is a constructor, okay? And this is what builds or constructs the object, okay? So the whole purpose of this constructor is to initialize those instance variables, the data that we came up with, to some starting value, okay? So setting the type or the breed or the size to an initial starting value. So there's two types of constructors that we might have. One would be called an empty or a default or a vanilla constructor. Any guesses why you might call it a vanilla constructor? Plain. Nothing fancy at all. Exactly. So in an empty or default or vanilla constructor, we're going to initialize everything to default values. So breed might be initialized to unknown, and age might be initialized to 0, and color might be, you might set something to a null value. But you're going to initialize everything to a default value, and then you'll change the values later on. Well, the variables all have to be declared up front. But it is for the case where I know I'm going to have a pet. Maybe you're saying, I'm going to get a pet, but I haven't bought one. I don't know what it is yet. Like I have a pet, or I'm getting a pet and I haven't picked it yet. So you don't know if it's going to be a cat or a dog yet or whatever. So then you fill in later. A lot of times you'll start with something, but you'll have some information, but there are cases, and we'll do a little bit of both. Our labs will show you all of these things as we work through those. All right. The other type of constructor is what's called an explicit constructor. We're explicitly providing some information to our constructor that we want to use to initialize our variables. All right. So we will be including specific information, like specifically it's a dog and it's a poodle and it is, 35 pounds kind of thing. We're providing explicit information. We will assign that information to our instance variables, and whenever we reference our instance variables, we're going to use the keyword this to indicate that it's an instance variable. I'm going to put all this together for you. Trust me on this. All right. Methods, on the other hand, are actions or behavior that's going to be taken on that particular data. So perhaps formatting an address label that builds the name of the pet and the breed and all of that could be printed out, or searching for all pets older than 10, and that sort of thing. What other things might we want to do with our pet data? Methods are like functions, yes. So if you're used to something called a subroutine or a function or a method or a module, that's essentially what methods are all going to be like. They're going to be little pieces of code that they can only act on the data, the instance variables that are inside of the object itself. So yeah, well, let's see. I hate it when I catch in front of myself. So let me move on to the next slide to make sure, and then I'll try to pull all this together. Well, it could be. It could be taking the, yeah, if you've built something like that in there, a method could be taking the pet to the vet. Great questions, guys. All right, so we could have compute age of the pet, print the label, change the name. Perhaps you thought you were getting a male pet, so you gave it this, name, this very big male name, and then you ended up with a female pet, so you need to change it to be a more feminine name. You could search for dogs in there, all sorts of actions that we could take on our data. All right, so on our methods, we're going to have, typically for us, we're going to deal a lot with set and get methods. So a set method would be changing the value of an instance variable, where a get method would be retrieving the value. We might have some search methods where we're searching through our data to specifically find something, some computations where maybe we have the birthday of the pet, and then you say, well, tell me how old this is in dog years and tell me how old this is in people years, kind of a thing. And then toString methods, which are methods that format output for us that we can then send to a printer or display on a console, that sort of thing. So these are the type of methods that we're going to be dealing with. All right, data types. When we're writing our code, we need to define these pieces of data that we're saying that we're going to need, like the type and the breed and the size and the age and the color, all of those things. We need to define that information to tell the computer, I need to store some data. I need to keep track of some information. So I'm going to store it, and we need to tell the computer what type of data we're going to be storing. Okay. So we have primitive data types. Primitive data types have no other actions associated with them, all right? And they always start with a lowercase letter. So the four primitives that we're going to be dealing with are integer or whole number data, double or floating point data, which has decimal places, Boolean, which is going to be your true or false, or ones and zeros, okay? And character, which is an ASCII, single ASCII character. Now, you guys have all seen ASCII. You may not think that you've seen ASCII, but have you ever noticed when you're browsing the internet that the address line up at the top, the URL, the address line at the top, how sometimes you'll see like the web address, and then it'll be like %20 something else, blah, 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 at the end of the, have you guys ever noticed anything like that? Okay. That %20 thing is the ASCII character for a space. Okay, so you've all seen ASCII characters and been using the whole ASCII code set. You just probably never really paid any attention to it. So a character is just going to be a single character. It's enclosed in single quotation marks, so just the one quotation mark on either side of it, and it's one character only, but how the computer stores is the ASCII code set behind the scenes. Okay. Var does not exist in Java. So we do not define our variables with the var keyword. All right, we also have complex data types, which are classes. So we'll be building our own user-defined complex data types, but there's a lot that we can take advantage of, which was what was referred to earlier as in like the Java libraries. So the complex data types not only have data that's stored in them, but they also have methods or actions that can be taken on that data. And one we're going to use all the time is the string class. Now you're going to start to think of the string class as primitive data because we're going to use it all the time, like all the time we're using it, but it's not primitive data. We just tend to think of it because it's such a basic piece of our data types. But there's lots of methods associated with a string. For instance, you can convert your string into all uppercase or into all lowercase. You can search a string. You can get the number of characters in a string. There's just a ton of methods that are built into the string class that we're going to be able to take advantage of, which are not available to us in our primitive data classes. So the primitive data types, the integer, the double, the Boolean, and the character, those all you get is data. Where with the complex data types or the classes, you get not only data, but also actions that can happen on that data. Classes, or these complex data types, always start with a capital letter. So our integer, double, Boolean, and char are all going to start with the lowercase letters. So lowercase int for integer, lowercase d for double, but your string, capital S, because it's a class. All right. So keep in mind we have integer, which is whole number, double, which has decimal places, Boolean, which is your true false, char, which is just a single character, and we have string data. So if we look at this for the interest rate, which data type would you select? Absolutely double, because there's always the possibility of decimal places. So if there's ever a possibility that a decimal place will exist, you want to go with either your double or floating point data type. How about a street address? And that's assuming it's the whole 123 Main Street kind of a thing. Okay, so it's definitely going to be string if we're looking at the full street address. All right, so this is a trick question. Social Security number. So when you're trying to determine if something is a number, you have to ask yourself, will I perform math on this number? Yep, exactly, Hassan. Did I say that right? So if you're not going to be performing math, it's not a number. So it's string. Okay? And also you have to keep in mind of Social Security, some Social Security numbers actually start with the number 0. And if you defined it as an integer, the 0 would be truncated, right? Because it's never, you never have that, the 0 at the beginning. It would just start with the next number. So an integer or double is only going to be for math. Yeah, if you're not doing math with it, then it's not a number, and you're going to stick with string. And it actually is more efficient to store something as a string than it is to store it as a number, because the computer has to allocate in memory for the largest possible number. Even if you're storing the number 1 in it, it has to allocate for the largest possible number 1. And so it's much more efficient to store as a string if you know you're not going to do math. Gender, represented by a single character of M or F. Yes, you're going to go with the char. And age. Yep, if we're just going with the straight age, we'll go with an integer. If somebody really wanted to be picky and know that somebody was 27.2 years old, then you would go with double. So in that case, it would just depend upon the situation. All right, variables. So when you need to remember something, what do you guys do? How do you remember that? Yes, yeah. If we did need to do a computation with the Social Security number, then we would want to convert it to a new number. Yep. Okay, yeah, that's excellent. All good things. So you need to put it somewhere. Now, being in the computer profession, I do not recommend that you write your password on a Post-it note and stick it to the front of your computer. Definitely bad. But you're going to write it down, store it, put it somewhere, right? And the same thing needs to happen in with computers. Is if we're doing a calculation and we need to keep track of that, we need to store it somewhere. But and so what we have is variables. So the variables in a computer program, you can think of it as the Post-it note to keep track of something. So you can think of it as your spreadsheet or your Post-it note or whatever you're writing it down on. All right, so that's what a variable is. The whole point is to let us to keep track of information. Okay, so when we're adding, we're computing, we're sorting through things, we need to remember a value, we're going to use a variable. And what a variable is, it's a pointer to a location in memory where data is stored. So it used to be way back in my assembler days, which were really long ago, we had to actually say this is where I want my data to be stored, I'd actually have the memory location, like put it at memory location hex alpha Charlie 782 kind of a thing. Now with the higher level languages, it's awesome because we don't have to do that. We just define our variable and say this is the name of my variable, this is the type of data I'm going to store in it, and the computer then finds a location in memory that's available and puts it there and maps it to my name. So I just refer to my name and the computer then knows that that equates alpha Charlie 172 kind of a thing. All right. So, and that's what this pictorial thing is. So maybe I come up with a variable name of animal type, then the computer, and I define it and I say I'm going to store string data here in this variable animal type, and the computer says, okay, I'm going to map you to this memory address and I'm going to store your value cat. And here we have age, and I'm going to map that to this one, and here's your value of 48. So the computer translates this into a memory address and then stores your data for you. Okay, now when you're choosing names for your variables, there's some very specific rules. No spaces whatsoever, no punctuation other than the underscore. You cannot start with an underscore or a number, or you could say it the other way, you can only start with a character, and it cannot be a reserved word. It cannot be a word that it represents a command in the Java language. Okay, so keep that in mind. No spaces, no punctuation other than the underscore. It cannot start with an underscore or numbers, or it has to start with a character. And it cannot be a reserved word. It cannot be a command that is used in the Java language. Okay, now when you're naming, so those are Java rules, okay? Yes, that is an excellent thing, Matthew, and I will start with that here. I'm going to mention that in just a little bit. So there's also conventions. So these are just like standards that are used in Java. They aren't required. So those previous rules, those would be a syntax error if you violate them. A convention will not violate the rules of the language. They will not generate a syntax error, but they're just standards that everybody follows. So one is it needs to be meaningful. It needs to be representative of the data that's stored in the variable. You want to be able to look at the variable and know, oh, this has a student name in it, right? You want to be able to look at it and go, this has interest rate. You don't want to look at it and see SN and go, what is SN? I don't know what that is, right? So you want your name to be meaningful. Variable names start with a lowercase letter. Okay, and typically you'll use something like camel case because they're easy to read. So camel case is the first one, starts with a lowercase, and then each word within then is capitalized. Now, Matthew brings up a great point here. You want to make your name meaningful, but you don't want to make it so long that you're constantly mistyping, or that you're like, oh my gosh, if I have to type this variable name one more time, I'm going to go insane. So you kind of want to use a cross between choosing a variable name that's meaningful but yet easy to type. And you guys will see as we go throughout this course, I am a horrendous typist. I like to think that I'm a good typist, but I am just not. Okay, and so I will constantly be correcting my typing, and so you want to create your names short enough so that you're not constantly mistyping them. Okay. So we're going to look at these variable names and let's see, do they follow the syntax rules? Like, will they compile cleanly so they follow the rules? So dog name, valid or invalid? Yep, valid. Excellent. Horse age, valid or invalid? Yes, invalid because it's got a hyphen, cannot have a hyphen, it has to have an underscore. First name, valid or invalid? Invalid, it cannot start with a number. Start time. Invalid, no spaces. So what the computer would do, it would look at it and it would think that was two variables. One variable called start and one variable called time. Okay, so definitely not valid to have a space in there. Time to finish, valid or invalid? Yep, valid. It's okay to stick numbers in the middle. You're just not allowed to have it begin. It might be outside the convention, but yeah, but it's valid. Okay, so now we're going to look at conventions. So does it follow the convention? So just the standards. So these will all compile, but are they the convention? So FN. So FN is just not very meaningful. If you were in an industry where FN was a standard abbreviation, then I would say it would be okay. It might be foot number, it might be first name, it might be, I don't know what else it might be. But floppy note, yep, anything along that. So it's hard to tell. If it was a standard industry abbreviation, then I would say it would be fine. But if you're in a program that this isn't a standard abbreviation, then I would say it's probably not a good choice. Animal type. No, it doesn't because A is a capital letter. Only classes should start with a capital letter. So animal type, yeah, should have a lowercase. GPA. Yeah, I would say GPA is a very standard abbreviation that if you were to say GPA to anyone, pretty much they're going to know what that is. Last underscore name. Yep, I would say that's a pretty good one. Follows all the conventions. Reserved word. Yeah. I mean, even though we don't want to use reserved words, the actual term reserved word is not reserved, so it would be fine and it follows Java conventions. Okay, when you're defining a variable, the format for defining a variable is data type, space, and then your variable name. And either one of these can be used, colon or semicolon. What this does is it says, hey, computer, I need to define this variable with this data type, and I'm going to be using this, so I want you to set me aside some space in memory, but I'm not giving you a value just yet. So this would contain a null value. It wouldn't contain an actual value, but the space in memory would be allocated and it would be ready to be used. This format, data type space variable name equals value, not only defines the variable, sets aside space in memory, but it also gives it an initial value. So, yep, definitely, Matthew, that would work great. So string data type space, the name of your variable equals hello world. It will do null here. This is going to contain a null value if it's a string, or if it's textual data, it'll do a string, it'll do null. For the other one, and it depends, Owen. Some of them, they're just not defined at all. Instance variables, I'm probably going to mess this up. Instance variables will not default to an initial value, but local variables will, or it's vice versa. It's always a good idea to set it to an initial value, and it's null with a lowercase n. Okay, so when we're defining variables, here how this would look. Integer space total seconds. So this says set aside the space in memory, but I'm not giving you an initial value. We have double space GPA equals 4.0 with a semicolon. We always end our statements with a semicolon in Java. They're not optional as they are in other languages. String, capital S, because string is a class, so it's complex data, not primitive data. String street address equals 123 Main Street, and those should be straight quotes, not curly quotes. And character grade equals A with a single quote. So double quotes define string data, single quotes define character data. Okay. All right, so if we were to look at writing something, so we're going to write a variable that contains the first, middle, and last name of a student. So what would that look like if you were to write the statement to define that? Okay, so you could definitely, it's data type string, right? Don't forget it's capital string because string is a class. And then you could go with student name. You could go with student, full name. You could do whatever, and you could set that equal to a value or not equal to a value depending. We may choose to break it up, and do a string, first name string, middle name string, last name kind of a thing, or we may choose to combine it all together. Either one of those is great. All right, I'm going to flip through this because we're almost to 9:30 and I still have like 6 slides left to go. So I'm going to flip through these last slides pretty quick so I can bring up the homework before we end. So I just came up with Stu full name, but there's no rule. Like this is going to be one of the most frustrating things, especially for you who have never programmed before. There is not necessarily one way to do something. Like I could define Stu full name, you could call it student name. Both are correct, both are fine. So there's no one exact way that you can do something. There may be more efficient ways to do things, but the goal is the end result. And if we both get to the end result, then who's to say my way is better than yours? Okay, so if we were looking for a variable containing the number of students in a class, we could do integer num students. Okay. If we're looking for something and it contains the batting average of a player and assign the value 2.79 to the variable, it would be W, and I know RBI is not batting average. I screw this up every single time, equals 2.79, okay? And a variable containing a code indicating payroll category and assign it the value of F would look like character or care payroll category equals F with single quotes. All right, homework. Let me pull this up. So for this first homework, it's all about just getting you familiar with things, right? So all the homework will have some sort of a question answer kind of thing here. So you're going to research and identify syntax and logic errors. And an identifier is a variable. So what are the rules for defining for constructing an identifier, okay? And then the next part of the homework, it's going to figure out the same way for each week. We're going to give you some examples of things, and there's going to be errors, and there's going to be both syntax and logic errors, and you need to find the solution for fixing them. So in this case, you're just trying to identify, is it a syntax or a logic error? In future assignments, we will have actually introduced errors and you'll have to fix the errors. And that's just to help you. So what I've done is when I created these homework assignments was to put in types of errors that I see all the time in students' assignments. So to help you familiarize yourself with the different types of errors so when you encounter them in your own code, you'll be able to fix them. So you'll have errors that you need to fix Here, you're asked to write the statement. So here, so in this particular statement, identify the type of data and a good identifier. Write the Java statement to define the variable. Okay, so you are physically writing the Java statement to define the variable. And we did a whole bunch of those here. We wrote the statement to define the variable. So this is kind of what we're looking at. So not only are you supposed to say, okay, permanent city, that's going to be a string data type, and a good name might be perm city, something like that. You can't just do that. You need to give me the actual Java statement to define that particular variable. And you're going to do that for all of these things. And remember, when you're trying to decide, is it an actual number? Just because it's called a phone number doesn't mean it's really a number, right? And also between integer and double, is there the possibility that there could be decimals? Because if it could have decimals, then you want to go with a double. Here you're describing the reason for the errors. So these are all different variables that define, but they're all incorrect. Every single one of them has an error and will not compile. So if you want to test it, copy it into BlueJ and try compiling it and see what sort of error message it gets for you, right? That's what the whole BlueJ tool is. So you need to identify the error and how it would be corrected in all of these statements. And then you're going to write a really, really basic program. Okay, so here's what's going to happen. You're going to create a pictorial version of a house, and you're going to do it using the characters on your keyboard. So first off, what you're going to do is you're going to take this and you're going to copy it. All right, you're going to bring up BlueJ and you're going to do project, new project, and you're going to drill down to some place